welcome you to this presentation on Introduction to AUTOSAR. What is AUTOSAR? Is it a software? Is it a hardware? Or is it any tool? Or is it any specification? What is it? AUTOSAR stands for Automotive Open System Architecture. So as the name itself suggests, it's an open system architecture for automotive software development. So it provides a standard for developing automotive applications. AUTOSAR is a consortium formed by OEMs, suppliers, semiconductor vendors, tool manufacturers, and even universities have joined this consortium to get the benefit of AUTOSAR. AUTOSAR is trying to standardize the ECU software. So what is the motivation for AUTOSAR? Why AUTOSAR came into picture? What is the real motivation? Why AUTOSAR consortium wants to standardize the ECU software? Is it not really standardized? There are so many ECUs in place. There are 70 ECUs in modern vehicles. Are they not standardized? What happened? Why AUTOSAR came into existence? Here are the few case studies. Before that, let us try what are the differences between non-standardized project and industry projects. What I mean by non-standardized projects are projects which are done at the university level or at the students level, and the projects that industry is doing. The basic difference, I think, first thing which comes to your mind is the repeatability, reliability, accuracy, and really I'm not talking about the characteristics, whatever I just mentioned. I'm talking about something more than that. For example, if somebody working on temperature controller, most often when non-standardized project is implemented, they only concentrate on the application side. So application side in the sense, they only write the application software. So what I mean by application software is, for example, I want to control the temperature. So if the temperature crosses 70 degrees centigrade, then I want to switch on the fan. If it is less than 50 degrees, I want to switch on the heater. So this is application software which majorly you focus on. This is application software that is written in many languages. It may be C or it may be Python. But when this application is built, they are not worried about the hardware, the communication software, or some communication hardware, or any peripherals. For example, if the temperature sensor has gone bad, so there is no software written to check whether the temperature is fine or not. There is no software written to check whether the hardware is fine or not, whether the controller is fine or not, whether the actuators are fine or not. So that is monitoring software. So in the non-standardized projects, we don't actually look into the hardware monitorings. But whereas in industry project, it is very, very important to take care of the underlying hardware. It is not only just the application software. For example, if you take a look at the ABS, anti-lock braking system, which requires the only input, that is wheel speed sensor input. If the wheel speed sensor is bad, then you can't actually invoke the ABS action. Instead of instead of releasing the brake, you may apply the brake, or instead of applying the brake, you may release the brake, which is very dangerous. That is the reason it is very important to monitor the hardware related to that software. Not only just that, even this non-standardized project doesn't follow any standards, coding standard for that matter. They don't follow any standards, and also they won't have any software to inform the user that some functionality is not working. For example, diagnostic software. If something is bad in the project, some sensor has gone bad, then the user needs to be informed about that. So the industry projects involve all these software components or modules. So every industry follows some standard. So there are n number of industries, for example, Bosch, KPIT, Continental, Delphi. There are the n number of suppliers which develop ECUs. Okay, so they follow some standard. Of course, there was a standard before AUTOSAR, but everybody were following their own standard. So there was no one standard, because of which AUTOSAR came into picture. So which is trying to standardize this architecture, standardize this software architecture for ECU development, specifically for ECU software development. So it provides a standard software architecture for developing applications, especially for automotive applications. Okay, another scenario I will tell you why this came into picture. Okay, let us say, for example, we have OEM X, and there are a number of suppliers, supplier 1, 2, and so on. So here you can see OEM X has some project with supplier 1. So for some reason, if that project is not going well and they want to ship to the supplier 2, okay, this project is not going good, and they want to continue that project with supplier 2 with some modification. So when OEM X goes to supplier 2, will it be possible for supplier 2 to add some new functionalities or make changes to the project which supplier 1 has done? Which is very difficult, because supplier 2 is not aware of what kind of hardware is used, what kind of software is used, what kind of standards are followed, what kind of software is written, what languages are used. So it's impossible or very difficult for supplier 2 to do any modification for the existing project. It is as good as new project for a supplier 2. So this is the problem that every OEM and every supplier is also facing, because suppliers cannot take the project which is done by another supplier. OEM cannot go from one supplier to another supplier for any modification or alteration. So that is the reason. So this was a problem faced by every OEM and every supplier. So that is the reason the OEM suppliers came together and formed this consortium called AUTOSAR. So as the AUTOSAR, it's a consortium formed by suppliers, OEMs. Okay, it is not only for particular OEM. So almost all the OEMs are now they are into the AUTOSAR consortium. So imagine, see, competitors are coming together and they have formed the consortium. So will it work? Yeah, of course it will work, and it has worked. Okay, that is the reason AUTOSAR has a slogan: cooperate on standards, compute on implementation. That means everybody has to cooperate in forming the standard and compute on implementation. Any applications they want, they can develop, but they have to follow this AUTOSAR standard. Okay, that is the reason the slogan says compute on implementation, cooperate on standard. Okay, why AUTOSAR and what are the challenges? You can see the growing complexity of electrical and electronics. Nowadays the modern vehicles have got more than 70 ECUs. Okay, there is a ECU to control the wiper, there is a ECU to control the mirror, wherever you place a hand there is a ECU. More than 70 ECUs are placed. Okay, so the electronics and electrical complexity is growing day by day. And the quantity of software is exploding. Okay, within the ECU and outside the ECU, also the software quantity is exploding day by day. There are different hardware platforms being used. It is not harmonized. Even the development process and data formats are different from one OEM to another OEM, from one supplier to another supplier. So these are the challenges before the AUTOSAR. What are the objectives of AUTOSAR? Yes, AUTOSAR wants to reduce the development time. How the development can reduce because of the AUTOSAR standard? So if everybody is following the same standard, then it's easy to reuse that same component. If there is a standard, then it is easy to test. Okay, if there is a standard, then you can use the same development methods and tools. So you don't have to buy another tool for testing the different ECUs. Okay, so you can make use the same functionalities across different OEMs. OEMs can go to different customers, different suppliers. So there definitely there's an improvement in the software quality because there is a reuse. There is a significant reduction in the development time. So for industry, time is money. If the time is reduced, definitely there is a huge profit. Finally, even the end customers also going to get benefit out of this because of the reuse. So these are the objectives of AUTOSAR. Yes, I did mention complexity is growing. There are more than 70 ECUs in a modern vehicle. The software is exploding. You can have a look at this example. This is the electronic stability program ECU. So it all started with just understeer and oversteer control. It also has got ABS. It also has got traction control, hill hold control, hill descent control, adaptive cruise control, start stop, electronic brake boost assist, brake disc wiping. So there are n number of functionalities being added in the same ECU. The only functionality which had was the understeer and oversteer control. But apart from that, there are n number of functionalities within the same ECU. The software is exploding within a ECU. Okay. Standard architecture for managing all these things. So different hardware platforms like Microchip, Texas, Fujitsu, Motorola, Atmel. So there are different hardware platforms are used. Different process methodology and data formats for exchanging the information between the suppliers and OEMs. So AUTOSAR is trying to address even the development methods and also the data formats. Okay, here's an example which I have taken it from the Vector website. So you can see this is the embedded stack for CAN. You can see there is a CAN driver here which is following a HIS standard. Okay, there is a ISO standard for a diagnostics layer. Okay, there is a OSEC German standard network management. There is a ASM standard for calibration protocol. Okay, so at different layers there is a standard, but there is no one standard. So AUTOSAR is trying to address and coming out with one standard. So who is AUTOSAR? Who are all involved? So this is a consortium found by the core 9 partners. Okay, like BMW Group, Toyota, Bosch, Daimler, Continental. So these are the 9 core partners involved in this AUTOSAR. So not only that, even the other OEMs also join this consortium, like general OEMs like Porsche, Volvo, Mazda, Honda. Okay, some generic tier 1 developers like Delphi, Denso, TRW. So these are the generic tier 1 developers, and also some tool developers like Vector also has joined this consortium. Tools and service providers like MathWorks, and see, these people can only give this specification. Somebody has to come out with the semiconductors. Even the semiconductor vendors also have joined this consortium like Freescale, Infineon. So you have also 21 development members and some associate members and attendees. Even universities can join this consortium as attendees and get the benefit out of this AUTOSAR standard. So who got benefited by this AUTOSAR standard? Almost everybody got benefited by this, but software IT giants got benefited by this AUTOSAR standard. Earlier, the hardware used to be sold as a product. Now because of this AUTOSAR standard, everybody is selling even the software as a product. Okay, because there is a specification available, there is a standard available, they can develop a standard and sell it. Okay, that is the benefit of AUTOSAR standard. I will use one example. If, for example, there is a ECU, electronic stability program ECU. So that ECU can be developed by some X supplier. Even the software can also be developed by that supplier. But part of the software within that electronic stability can be taken from other suppliers. So that is the power that AUTOSAR gives. So it standardized the the software architecture so that anybody can plug in new software into this. So they can plug in directly in their software into this AUTOSAR architecture. So that is the standard that this AUTOSAR provides. So these are the premium partners. So every partner has got different rights and duties. So premium members has a right to use AUTOSAR technology royalty free with a free of charge license for automotive applications. They can access the AUTOSAR information and specification. They have some leadership of and cooperation in working groups. So they can use the AUTOSAR technology royalty free. So free of all the IPs developed by other AUTOSAR partners. So developer partners also have some rights. So they can use the AUTOSAR technology royalty free. So they can access the AUTOSAR related IPs and access the AUTOSAR related IPs of all other AUTOSAR partners free of charge. Access the information related to AUTOSAR specification. So associate partners, they don't have right to use the AUTOSAR IPs, but they can definitely use the AUTOSAR technology royalty free and access the information. Attendees, they don't have right to use AUTOSAR technology royalty free, and also they don't have any right to use AUTOSAR technology or IPs developed by other AUTOSAR partners. So they can only just access the AUTOSAR related information and specification. Universities join the consortium as the attendees. So these are the targets and goals of AUTOSAR. So it lies at the development process and action format, that is methodology and templates. So it focuses on standardizing the functionalities, that is functional interfaces between the application software, between the RTE and between the basic software. So the RTE is the runtime environment which abstract the application from accessing the hardware or the BSW models directly. So all the standardization of AUTOSAR lies at the BSW, that is basic software modules. So this BSW basically consists of the drivers for microcontrollers, communication drivers, memory drivers. So different kinds of drivers this basic software consists of. Okay, so most often this the MCAL layer within the basic software is provided by the semiconductor vendors.